Okay, everybody, we're going to try some more molecular structures. Yay! And this time we're gonna run into situations where, in order to make the octet, we're gonna need double bonds or maybe even triple bonds. Okay, so anyway, let's get started. Really, the steps are going to be the same as what we were following before. We're just going to run into a situation where, we haven't made the octets that are needed, and we need to use double bonds to make that happen, or maybe triple bonds to make that happen. All right, let's get started with our first example. Okay, so let's go with, let's see, how about carbon dioxide? Okay, so carbon dioxide. We're going to start with counting the valence electrons. So carbon has 4 valence electrons. Oxygen has 6. We have 2 oxygens, so that's going to be 12. All right, that's going to give us a total of 16 valence electrons to work with. All right, as always, we're going to start with a skeleton structure. I'm just going to start with single bonds. Why not? I know that's not going to work, but let's see what happens, okay? So I used 4 electrons when I made these bonds. So I'm going to take 16 minus 4, and that's going to be 12 leftover electrons. Let's distribute those electrons around this molecule and see if we've created octets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is not going to work, okay? I'm fine with the oxygen. I've got octets there, but I only have 1, 2, 3, 4 electrons around carbon. This is not going to work. Let's try something else. Let's try a double bond and see how that works. Okay, so again, I'm working with 16 electrons. Now I've used 2, 4, 6 electrons in making my bonds, and that leaves me with 10 leftover electrons. Let's see what this does for us. We're going to distribute this 10 electrons around our molecule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, that's fine. We've got bonds, we've got an octet around our oxygen here. This is an octet around the oxygen. We've got another octet around this oxygen, but we've only got 6 electrons around this carbon. Let's try 2 double bonds and see what happens. Okay, so we've got carbon, oxygen, carbon, oxygen. Okay, and we have 16 valence electrons. This time we used 8. We're going to have 8 leftover electrons. I'm going to distribute that 8 around this molecule. 1, 2, 3, 4, 5, 6, 7, 8. Bingo, we got it. We've got 8 electrons around this oxygen. We've got 8 electrons around that oxygen. We've got 8 electrons around that carbon. This is great. We're good. We're done. Let's try another one. Oh, and by the way, maybe I should say this is the answer. We got that. Okay. Okay, let's try a situation where we are going to need a triple bond. So I'm telling you up front that we're going to need a triple bond for this one. We just went over a scenario where double bonds were necessary. So anyway, why don't we try this molecule? This is called hydrogen cyanide, and in fact, this is also in the note packet. Why don't we give this a try? We're going to count the number of valence electrons. So the valence electrons in hydrogen is 1, carbon is 4, nitrogen is 5, That's going to give me a total of 10 valence electrons. Okay. I'll start with a skeleton structure. Carbon is going to be in the middle. Just to tell you up front, really, if you see carbon in a molecule, most likely it's going to be in the middle. And I'll just start with something I know is not going to work. Okay. But like we've been doing, we're going to work off of this bank of 10 valence electrons. I've formed 2 single bonds here. That's 4 electrons being used. So that would leave me with 6 leftover electrons. 1, 2, 3, 4, 5, 6. Okay, well, that is not going to work. I do not have an octet around carbon, so that ain't going to work. All right. Now, I have seen this in class from some of you where you tried like a double bond with carbon. Don't ever do that. That is never, ever, ever going to happen. It's totally impossible. So let's start over again. So I've got hydrogen, carbon. Let's try a double bond with the nitrogen. So 10 valence electrons minus 6 in the bonds gives me 4 left over. 1, 2, 3, 4. Well, that's great. I've got an octet around the nitrogen, but only 6 around the carbon, so that's not going to work. So our first attempt doesn't work. Our second attempt doesn't work. Let's now try a triple bond. All right, 10 electrons minus 2, 4, 6, 8 electrons. Leaves us with 2 left over, and we have 2 at the nitrogen. Okay, so that's 2, 4, 6, 8 for nitrogen, 2, 4, 6, 8 for carbon, and 2 for hydrogen. This is our structure, and that should do it for this video. All right.